Okay, so we're going to start with the 4-3 really quickly, though. Put my book somewhere. All right. So I'm really sorry about yesterday giving you that first one. It was horribly. Ugh. And they're really there sometimes, but I really understand why I have to give you one of those because it's it really teach you more to use fractions. Not really, right? Just gives you more challenges. But anyway, here we go. Okay. You guys want another one like what we did on that last one? Yeah. It has different themes. Okay. All right, so we have once again a system of equations, right? Three unknowns, so that's why we have to have three equations. 2x plus z. I think we didn't get crossed all the way. Sorry about that. Okay. And by the way, if you miswrite something down, that's when these guys get really bad. So if he became a negative z, that's going to change this whole thing out. And so make sure you always are copying down exactly where we're at, just so we're right on top of it. Okay, so as I'm looking at this again, have three equations, and notice I have three different types of equations, one with just x and z, one with x and y, and one with y and z. So I have all possibilities thrown back. So therefore, I'm just looking for the easiest way to eliminate a variable, because I notice once again I have something in every other case. So who would probably be the easiest to eliminate? Well, it's either, to me, I'd eliminate this y or these z's. I guess even him wouldn't be too bad, but one way or the other. Does that make sense? I'm going to go ahead and do the z's. Okay. So I'm going to go ahead and multiply the top row by 1. 2. So I have 4x plus 2z equals negative 14. And to be honest, I like to use different colored pencils when I do this, or pens, just so that I can write in different colors and say, so I don't get too long on my paper, because a lot of people don't like to keep wasting. Landon, I swear he cut down a damn tree by himself last time he found a piece of paper. He said it was awesome. Right? But seems like having one problem per page. But it would eliminate him, but once again, we were determining to get rid of this. So it really doesn't matter what we so choose, because right there, I can eliminate either one, to be honest. Okay? But once again, we designated that we're going to eliminate the z. Okay, so when I add this row and this row, 4x plus 0 is 4x, right? And it's kind of nice in a way. Watch what's going to happen in just a second. 0 plus 3y, 3y. 2z minus 2z, 0, which our goal was to get rid of that, right? Okay, and negative 14 plus 7. If you need to, help me name again right here. If you need to scoot your desk over just so it's easier so you don't have to bob and weave, you're more than welcome to, and just scoot it back at the end if you wouldn't mind. Equals 3. Is everybody there with me? And then notice we have this one. Another reason, it's a great way, another nice reason why we have that one, because look, it's going to be an easy elimination on this one, isn't it? Right? Because those x's are just going to go whoop right out of it. I don't even have to manipulate them. I just got to add them together, right? So I get 2y equals 10. So y is 5. And really, guys, once again, I can come back in here and solve for z, come in here and solve for x, just using what we had at the beginning of our equation, right? Yes. No problem. So do you see how in red I manipulated the top row? Okay, so that would become the 4x. Notice I have 0y here. Plus 2z equals negative 14. You with me there? I added, so basically what I did was I went 2 times row 1, and I added that to row 2. That's how I got this result. So once again, 4x plus 0x is 4x. 0y plus 3y is the 3y. 2z minus the 2z, gone. Negative 14 plus the 7. You with me now, Julia? Good? Okay. All right, y is 5. So I'm just going to come over here. Y is already 5. I'm going to plug and chug. Okay. So I have negative 4x minus 5 equals 7. That's negative 4x equals 12. So x is negative 3. Okay. And then probably come right here on this equation and just plug the y in and solve for z, right? Or I could go into the top, maybe that one, because z's by himself already. That might be the nicer one to plug it in. Okay, so what was my x again? Negative 3. So I had 2 times negative 3, which is negative 6, plus z. What did that equal? Sorry, I can't see it. Negative 7. Thank you, guys. So if I add the 6 over, z becomes negative 1. So my answer, once again, would be negative 3, 5, negative 1. Okay? Not too shabby, right? Now, those are some, once again, those ones aren't as hard because really I'm not doing as much work to get down to the 2 by 2, correct? I only have to manipulate one row to then use another one, correct? So let's get a little bit more intense, okay? Get a little more intense here. And let's go with this one. And I don't know the answers to any of these guys, to be honest. So I'm just rocking and rolling, but I'm confident in myself. I'm sorry, I'm a big dork. There we go. Take a little time to write that down. For those in the back, is this large enough? You guys are good to see and everything. Is that like a jumper? I always want to wear a jumper. I did wear my incredible suit that I wore for Halloween. JP, you already got your Halloween costume now, Jacob? I can see you planning it early. Ooh, right? I like the new beard coming in. So, you know, the outline. Sometimes I wish I had darker hair for that reason. Okay, you good? Everybody wrote it down? All right, what do you guys think? What do we got? What? Because once again, we got to eliminate a variable, right? Twice. So who's probably the easiest one to eliminate twice? X isn't bad. Really, Y isn't bad, and really Z isn't bad, is it? Any of them aren't too shabby. Okay, we're going to go with what Ashley wants to do, though. Just because I picked you, Ashley. Which variable do you want to get rid of? X it is. Okay. So how can we eliminate X really easily? Top and the bottom, I can just go row 1 plus row 3. Okay. R1 plus R3. And what do we get? X minus X is 0. Y minus 4Y is negative 3Y. Z plus Z is 2Z. 5 minus 6 is negative 1. Does everybody understand how I received those? Now, because we eliminated the X, that's what I have to go after again, don't I? Okay? Even though that this eliminating this Y would be easy too, right? But I have to go after the same thing. I have to eliminate x again. Now notice, remember, I use row 1 and row 3, so automatically I have to use row 2. Now does it matter who I use it with? Whether row 1 or row 3? No, but I have to use row 2 for sure. You guys agree with that? Okay? Make sense? All right. So I'm going to manipulate row 3 because it's already got the negative. Does everybody understand why I'm going to go using him? Because he's negative and row 2 is a positive, so I will use him. Okay? So I'm going to multiply row 3 by 3. So row 3 is going to be multiplied by 3 and added to row 2. Here's what it is, though. It would be negative 3x minus 12y plus 3z equals negative 18. So in the black is row 3 by 3, right? Times it by 3. Do you see what I did there? Just took row 3 and multiplied it by 3. When I go ahead and do this operation of row 3 times 3 plus row 2, I get 0x minus 8y plus 4z minus 2. Okay? Any questions on where I received my new row? Now, how many of you guys think this is going to be on your test? Well, these are going to be on your test. How many of these do you think are going to be on your test? Probably 2. Because if not, then we start getting time issues, right? Probably no more than 2. All right. So then once again, we're working within these two guys right here. Okay. Decatur, which one would you think is easier to eliminate, the y or the z on this one? Probably the z, right? Because once again, I don't have to manipulate both rows, only one row, correct? What would I times the top, Decatur? Times it by not only 2, but a, because then therefore it would be negative 4, right? So I'm going to times him by negative 2. So I get 6y minus 4z equals 2. Go ahead and subtract, add those together, which would become negative 2y equals 0. So y is 0. Cross country, where you run for fun. We should get evaluated. Sprinting and running are different, right, Chloe? That's right. Okay, y equals 0. Okay, so now I'm going to come back in here and plug that in for y. One of these guys, right? Doesn't matter which one. Nope, I'm going to use the top, though. So it's negative 3 times 0. 0 plus the 2z. So I basically have 2z equals negative 1, right? So z is negative a half. Oh, we got a fraction, but we can deal with it. What I would look for, though, now when I'm solving for x, is maybe, ooh, that's not going to be very fun. Okay, so here we go. Let's look up here. Probably that top one looks pretty good to play with. You guys agree? Because it's just x, y, z. Okay, so I'll just bring that down just so we can see really quick. X, y, z. So x, our y value was 0. Our z value was negative a half equals 5. Was it 5? You don't have it on your paper. 5. Okay, then we're going to add the half. But once again, when I add fractions, what do I have to do? Either there's 2 ways. So just like Abby brought up, she didn't maybe want to play with it. So what could I do is just times everything by 2, couldn't I? Does everybody see that? So I could have 2x minus 1 equals 10. I'll show you how that works, and I'll show you the both ways that we can get the same answer. 2x equals 11. X is 11 halves. Or, what is 5 in terms of halves? Isn't that 10 halves? Correct? Any common denominator? So if I add the half to 10 halves, what do I get? 11 halves. Still got the same results. What do I have? 11 halves, comma 0, comma negative a half, I believe is negative. Okay. Somebody's having fun in math, and that's not allowed. Yeah, you should be. Okay. We ready to rock and roll on the next one? You think this is good enough, adequate? We're good to go? Okay. All right, so let's go ahead and go on to the 4-2. 4-2 is complete story problem. Okay? You guys have a mental block when it comes to story problems. You're like, no! Okay? All right. So 4-2 once again. Story problems. I'm just going to dig right into it. And we'll do as many as you guys want to do. We have an hour about, so if you guys want to do 20, we can get through 20 if we can. I'll do all we can. Because the more we can do, the better we'll be, right? Okay, so I actually have, oh, that's right over there. Never mind. Where do I have it? Yeah. Nope. 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 Yep. There we go. Okay. So let's look at the top where it says example 1 here. Let's try not to look at the word quite yet. And then we'll go from there, okay? So the Cummings family and the Freese family went to a baseball game. In the second inning, Mr. Cummings bought 4 hot dogs, 3 large Cokes for $22.25. Seventh inning, Mr. Freese bought 5 hot dogs, 4 Cokes for $28.50. Okay, how much does each hot dog cost and how much each Coke cost? Okay. All right, so what's our variables here? Hot dogs and Cokes, right? Because that's what we're looking for, right? We have 2 different people buying the same product, but it comes out to be different because obviously they're buying different amounts. Right? Okay, so once again, 4 hot dogs, 3 Cokes, okay? And 5 hot dogs, 4 Cokes. I'm going to come back to here if we need to flip back and forth. I think it was, how much was the first guy? 4 hot dogs, 3 Cokes? Yes? So 4 hot dogs plus 3 Cokes. I think it equaled 22 something. 22.25. Okay. And did you have the other one written down? 5 hot dogs and 4 Cokes. Didn't get the amount. Okay, so let's take a gander. $28.50. Okay. Notice, guys, what is this? This is money, right? Okay, so what's our answer going to be in terms of? Money. Or it could be in terms of hot dogs and Cokes, depending on what they gave us. Let's say that, oh, I guess that was it. That's right. Okay, so we just have a system of equations. Pretty easy, except this time we have decimals. Now, if it starts with a decimal, am I okay to end in a decimal? That's usually the key. Okay, if not, I would like you to be in fractions too. Okay? But once again, because it started in decimals, I'm okay. All right, so Hiram, since you're out on your phone and you decided to pull that out, I get to pick on you. I love you anyway. Hiram, which variable do you want to eliminate? H, okay. So with that being the case, I know you weren't here, Hiram, but what am I going to have times the top row by? So my question I'm going to ask you is, can I make a 4 look like a 5? I could, but it deals with fractions. How many of you guys want to times by 5 4? Not one of you. So can I make a 4 look like a 20 and a 5 look like a 20? So what am I going to times the top by? Negative 4. If I've got to do one of them by negative. You guys agree with that? So I'm going to times the top by 5, and I'm going to do the bottom by negative 4. Or vice versa, the negative just has to go on one of them, correct? Are you freaking kidding me? All right, this is the plan, guys. I'm going to just keep going so we can get through because we don't have as much time.
So we're about to start. Hiram just told us to go ahead and multiply by 5 and -4, right? Or excuse me, Decatur said that. Or whatever. Somebody. I'll go with that. Okay. So as I multiply by 5, I get 20H plus 15C equals, that's 110. So what is that? 112.25? 111. Oh, I was off. Sorry. Okay. So then this guy's negative 28 minus 16C equals, that's 100 with 350 times that by 414. 114? Okay. Okay. So I have negative Cokes equals negative 275. So a Coke is 275. Darn those people that actually make that much money on Coke today. So I stopped drinking fresh stuff. $3 for a Coke. Come back to the top. Doesn't matter which one. No, right? Because they're both not the prettiest. So I'm just going to use the top 4 hot dogs plus 3 Cokes. Was that 22.25? I think this is 8.25. Is that a correct statement? Can you help me out? Okay. I'm going to subtract that. What do we have there? 14, right? 22 minus 8, right? Hot dogs is 14 divided by 4, but once again, down to be 350. Okay. Good. Try another one. So you guys catch up really quick though. Is that something cool or something like that? Okay, here we go. We're going to go to example 5 here. Blending coffees. Okay, here we go. Read this one. It says, the manager of a coffee shop wishes to form a blend of coffee. He wants to make Sumatra beans, noted for their strong, distinctive taste, that sell for $12 a pound, and a more milder bean, a Brazilian bean, that sell for $8 a pound. She wants to get 50 pounds of this new blend. Okay? So that's an equation right there, huh? What are we going to be adding? The Sumatra bean, which we're going to go with S, okay, plus the Brazilian bean. What do those two have to add to be together? $50. Right? You agree there? Okay. Going back to the story problem. Okay. The new blend will sell for $9 per pound, and there will be no difference in the revenue, and the selling of the new blends will be just the same. So that doesn't matter. Okay. So some things. How much did the original, whatever this bean called, Sumatra bean cost? $12. That's important, right? How much does it cost per pound for the other bean? 8. But in the end, after I mix it all together, she wants it to sell for $9 a pound. Okay? So as I write this, here's what we got. If we have 50 pounds, how much are we going to make out of that blend? How much are we selling that blend for? $9, right? We can say that we're selling the blend together for $9. So how much is she going to make out of this, out of 50 pounds? She's going to make $450 out of that. Does that make sense? So when I add the two beans together, shouldn't their cost equal $450? Does that make sense where I'm coming from there? Okay. So as I look at this, how much was the Sumatra bean? $12 for every pound of that Sumatra bean, right? Plus $8 for every Brazilian pound. Okay, and that makes sense. Who's going to have more in there? What should our answer kind of realistically be? Should I have more Sumatra beans or should I have more Brazilian beans? If my cost went from $8 and my other one's at $12, but notice what we're selling for is closer to the $9 range, which is closer to the Brazilian, right? So would you guys assume that we're going to have more Brazilian bean than we will with Sumatra bean? Does that make sense? Kind of realistically thinking in our head what the answer should be. Okay? All right. Then there's just a system of equations here, right? What am I going to times the top one by? Help me again, name. Ash? No, that's Ashley. Dang it. Haley. Sorry. What am I going to times and what by? What row and how much? By how much? -8. She wants to go -8. Everybody agree with that? Jamie, is that what you were saying too? Okay. So -8s minus 8b equals 400. Okay. -400. Thank you. We add those together. 4s equals $50. So S is 1250. So she's going to use 12 pounds, 12.5 pounds of the Sumatra bean. Okay, how much is she going to use for the other bean then? The Brazilian bean is 38.50. And I can do that just by saying what's 1250 plus what gives me the 50. Okay, this one's a little tricky. Because a lot of people, guess what they usually do? You see how this is in terms of money? Okay, if this is ever in terms of money, usually this over here is your money as well. So sometimes people put 9. Why is it the 450? Because it's 9 by the number of pounds. Isn't that what this is saying? I'm $12 for every pound. 8 for every pound. 9 for every pound. But how many pounds of that will I have? 50 of it, hence the 450. Okay, that was the part when I was young I would always struggle with. Okay, sometimes just seeing them is what we got to do. Okay, like I said, I want to hit as many as I can. Okay, let's see what else we got. Hey, I got it right. 3750. Holy moly, I was wrong. Because that adds up to be 51, huh? I'm a silly rabbit. I love chips. That's one of my favorite foods. Decatur, are you a cereal eater? That sounds really weird. But yeah. Okay. All right, here we go. We're going to go to another example. All right, have you guys ever seen those jet ones? Talk about an airplane. Here we go. Airplane. An airspeed of a plane is speed in the air. The speed contrasts with the plane's ground speed, blah, 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 because once again, when you're in the air, what's happening? You have your speed plus what else? Usually some kind of wind speed. I don't know if that's taking there. We'll read it, though. Here we go. So the ground speed of the airplane is affected by the speed of the wind. Oh, we talked about that. Suppose the 7 blah, blah, blah is flying west from Washington, D.C. to San Francisco, a distance of 2,400 miles that takes 6 hours. The trip east, though, only takes 4 hours. Once again, they're probably flying the same speed, but that wind helps us, doesn't it? Has anybody ever been on a trip that one way it takes a lot longer than the other way? Because once again, the wind up in there, right? Depends on what up in those wind currents can help us out. Okay? So, information. Notice first off, 2,400 miles, right? 6 hours one way, 4 hours another, correct? Those are our important information. What do we know about distance? We should know this from another class or before. What do we know about distance? Distance equals what? You ready? Rate times time, correct? That's our formula. Anybody not know that? If you think about I'm going 60 miles an hour and I go for 2 hours. My rate's 60 miles an hour. Time is 2. Essentially time zone. That's why we get 120. Correct? Okay. How many miles did they travel? 2,400. Both ways, correct? You guys agree with me? Okay, well, remember when they went back east, or excuse me, back west from Washington to San Francisco, they took 6 hours. So do you think the wind helped them or hurt them? Hurt them. So it's our airplane speed minus the wind speed. Is it not? Okay, and how long did it take them to do so? 6 hours. That's our time. With me so far? Did they teach you this in Texas? Okay. Now coming back, it only took us 4 hours. So therefore, did the wind help us or hurt us? It helped us, so it's our airplane speed plus the wind. How many of you guys have ever rode your bike? It's a windy day. And when you're riding against the wind, does it even make you feel like you're even moving? Because you're taking your speed, subtracting the wind speed, and that's really what you're traveling, right? Okay, so kind of think about that. All right. So either A, guys, I could distribute it through, or what else can I do? Notice if I just divide them, watch what happens when I divide them. I get 400 equals A minus W, and 600 equals A plus W. Why did I do that? When I add these two together, don't I already get rid of something? Hey, I saw your thing, but you're coming on Friday, right?
Yes.
The classroom. Okay, so Sharon was C134. Yep. Okay. So, these two rows, I don't have to manipulate anything, do I? Wish you hadn't stopped me. I know I'm boring. I just want to make sure you guys are understanding it. Okay? I add those together, I get 1,000 equals 2A. Does everybody agree with me? So our airplane is traveling 500 miles an hour. How much is our wind speed then? 500 plus what gets me to 600? So the wind up there was 100 miles an hour. That's not like a hurricane wind. Okay? Yes, sir. Uh-huh. Okay, so the reason how I would say is they're going the same distance, right? They're both going 2,400 miles. It's just a different time. One was 6, one was 4. So I understand because it took me less time. The one with the less time means that I'm going faster. Exactly. So I determined, hey, I have to be going faster here, so I'm going to be thinking help with this help. You with me on that? Whereas the other one, it's longer, so therefore it's 30. Answer your question? Okay. Let's see what else we got. Like I said, I'm trying to count some in here. I'm surprised that we don't have bigger ones. Let's look at 4-3. I'm going to go in there just to make sure there's another word problem that we do with the 3 equation. All right, here we go. Number 6 here. It says a swing set manufacturer has 3 different types of models. The Monkey requires 2 hours to cut wood, 2 hours to stain the wood, 3 hours to assemble. Here, somebody write that down for Monkey. 2 wood, 2 stain, 2, 3 assemble. It's not on this one. It's out of this thing. Okay, the Gorilla 3 hours of wood, 4 hours to stain, 4 hours to assemble. King Kong requires 4 hours of wood, 5 hours of stain, 5 hours to assemble. Okay. We have a total allotment of 61 hours for wood, 73 for stain, and 83 for assemble. What should we manufacture every day? Because we want to maximize our time, don't we? Does that make sense to everybody? Okay. So is it going to be perfect, maybe? Well, okay. All right. So what are our restrictions on this as I continue on? Like I said, I'm going to go right up to the bell. So if I don't get through, you guys are more welcome to get out and go, but just try to get as many as we can. Okay. So we have different kinds. We have our monkey swing set, our gorilla, and our King Kong, right? You guys agree? Okay. How many hours do we have for wood? What did it say? 61? Is that what it was? 61 hours for wood. Well, how many hours do we have for the monkey? 2 hours for the monkey. Now notice this is wood. So what am I putting in front of my variable? I'm putting wood. What would I do here? What was the next one? Stain? How many hours for stain? I'm just going to set it up so you guys can go. How much for stain? Let's just, how many total? 73? Something like that. Okay, so this would be 2 monkey plus however many gorilla, I don't know, guys, I apologize, plus King Kong. Okay, put the hours that it's going to take. This is, remember, wood, so put the hours of wood. This is your stain, so put the, notice I think it was 3 hours for monkey and so forth. Does that make sense? Homework, okay? You're just going to do odds, but I would try as many as you can. For 4.3 or 4.3, yes, just do the odds. I will have a video for later today, because obviously I'll have the whole class. So if you want to see more examples, you can check the video. If you do want to turn in your homework, go ahead and put it in. If not, just hold on to it, we'll turn it in next time. I'm okay with either or. Thanks, guys. Sorry about it's not my fault, but wish we could have got in some more.